Hello, curious minds! In a previous video, we dived into the mystery of Planet 9. But what if this elusive object isn't a planet at all? Could it be something far stranger, a phenomenon we've never seen before? Today we'll explore the wildest theories about what could be lurking at the edge of our solar system. And if you haven't checked out our deep dive on Planet 9 itself, be sure to watch that for the full backstory. Now let's uncover the secrets of the unknown. One of the simplest explanations for the mysterious gravitational effects isn't a single massive object at all. It's a cluster of smaller objects working together. Like a collection of dwarf planets, asteroids and other icy bodies from the Kuiper Belt, far beyond Neptune. Now, you might be thinking, a cluster of dwarf planets? That doesn't sound very exciting, but hold on, because even the smallest things can have a big impact. Think about it. Gravity is the fundamental force that dictates the dance of the cosmos. It's what holds our solar system together, what keeps Earth in orbit around the sun, and what causes tides to rise and fall. So, imagine a whole bunch of dwarf planets or asteroids, each with its own gravitational pull, all hanging out in the same region of space. Their combined gravity could be enough to tug on other objects in the Kuiper Belt, creating the same kind of gravitational anomalies that led astronomers to suspect the existence of Planet 9 in the first place. It's like these smaller objects are teaming up to mimic the gravitational pull of a much larger planet. But there's a problem. To create the effects we've seen, this cluster would need to be incredibly massive and arranged in a very specific way. And so far we haven't found enough evidence to support that idea. The number of objects we've detected isn't nearly enough to explain the observed gravitational forces. Still, this theory is a fascinating possibility. As our technology improves and we map more of the Kuiper Belt, who knows what we'll uncover? Now let's step into even more mysterious territory. What if the gravitational effects we're observing in the outer solar system aren't caused by an object at all, not a planet, not a cluster of smaller objects, but by something entirely invisible? One of the most fascinating theories is that a dark matter halo could be responsible for the strange gravitational anomalies. The gravity from this halo could create the kind of disturbances in orbit we've seen, making it seem like there's an unseen, massive object influencing the motion of distant planets and objects in the Kuiper Belt. Imagine it this way. We know the Milky Way has a dark matter halo that extends far beyond the visible parts of the galaxy. Could our solar system have its own smaller dark matter halo? It's a bold idea, and it would explain the gravitational effects in a way that doesn't require any new large object to be found. The tricky part, of course, is that we can't see it or detect it directly, and while its existence is supported by indirect evidence, proving that a dark matter halo is the cause of these anomalies in our solar system would be incredibly difficult. Let's move on to another intriguing possibility. A massive disk of debris. Now, we're not talking about your average everyday dust bunnies here. We're talking about a disk so vast, so spread out, that it could be influencing the orbits of objects in the outer solar system. Think of it like this. Imagine a giant ring of icy debris, rocks and dust, leftovers from the early solar system, orbiting the sun far beyond Pluto. This disk could consist of ice, rock, and dust, remnants from the early solar system or material left over from past collisions. Even though it might be incredibly diffuse, it would still have mass and thus exert gravity. And remember, gravity is a very weak force, but it acts over incredibly long distances. So, even though each individual particle in this debris disk would have a tiny gravitational pull, the combined effect of all those particles spread out over such a vast area could be significant. The challenge, of course, is that we haven't directly detected such a disk. While we've observed debris disks around other stars and galaxies, nothing of this scale has been identified in our own solar system, at least not yet. And just like with the other theories, the difficulty lies in proving its existence. This disk would be incredibly faint, and finding enough evidence to confirm it is a major challenge. Now let's take a step back and consider something that might seem a bit anticlimactic. What if we're simply misinterpreting the data? I know, it's not as exciting as a hidden planet or a halo of dark matter, but sometimes the simplest explanation is the best one. Remember, science is all about testing our assumptions, questioning our biases, and being open to the possibility that we might be wrong. In the case of Planet 9, the evidence we have is based on subtle gravitational influences on other objects in the outer solar system. These influences are incredibly difficult to measure, and it's possible that there are other factors we haven't accounted for that could be skewing our observations. For example, it's possible that there are more objects in the outer solar system than we realize, and their combined gravitational influence is what we're interpreting as Planet 9. Or, it's possible that our understanding of gravity itself is incomplete, and there are subtle effects at play that we don't yet fully comprehend. Overall, the data we're working with is still limited. So while the idea of Planet 9 or some other hidden object is exciting, it's also possible that the anomalies we're seeing are just the result of incomplete or misinterpreted data. As we gather more information, refine our models, and improve our technology, we may find that the solution to this mystery is simpler than we thought. What if the gravitational anomalies we're seeing are caused by something truly exotic? Something completely different from a planet or even a typical star? This idea introduces the concept of an exotic object, a strange cosmic entity that doesn't fit our usual understanding of celestial bodies. One possibility is that these gravitational effects could be caused by an axion star, a theoretical type of star composed of axions, which are hypothetical particles that could explain dark matter. Axions, if they exist, are incredibly weakly interacting, meaning they wouldn't emit light like normal stars, making them nearly invisible to our telescopes. But they would still have mass, and therefore they could exert gravitational pull. So, an axion star in the outer solar system might be too faint to detect directly, but its gravity could be enough to influence the orbits of distant objects, creating the gravitational anomalies we've observed. The cool part? If we could find one, it could not only explain these anomalies, but it could also offer valuable insights into the nature of dark matter, which is one of the greatest unsolved mysteries in physics today. And it's not just axion stars we're talking about, there are other exotic objects that could also fit the bill, like strange massive objects or remnants from the early universe. These objects might not shine like stars or planets, but their gravitational pull could still affect the solar system in ways we're only beginning to understand. Now I know what you're thinking. You're losing it, this is getting ridiculous. And you're right to some extent. These are all highly speculative ideas, and there's no direct evidence to suggest that any of them actually exist. While we can't yet point to any definitive evidence of such exotic objects, the idea that something entirely different could be influencing the solar system's gravitational dance is an exciting possibility. So, who's to say that these exotic objects, as strange as they may seem, couldn't actually be out there, lurking in the depths of space? What if the gravitational anomalies we're seeing in the outer solar system are caused by an invisible compact object, one that's small, but incredibly dense? Let's venture into even more mysterious territory, a primordial black hole. A primordial black hole is a hypothetical type of black hole that might have formed in the early universe, right after the Big Bang. Unlike the black holes we typically think of, massive ones that form from dying stars, primordial black holes would have formed from high-density fluctuations in the very early stages of the universe's expansion. These black holes could be much smaller than stellar black holes, possibly with masses as small as that of a planet. And here's the kicker, they would be nearly impossible to detect directly. Why? Well, just like any black hole, they don't emit light, and since they're smaller and more diffuse than the ones formed from collapsing stars, they would be very difficult to spot. But despite their invisibility, primordial black holes would still exert a strong gravitational pull. So, if one of these primordial black holes were lurking in the outer solar system, its gravitational influence could be enough to cause the anomalies we've been observing. But here's the challenge, we've never found any definitive evidence of primordial black holes. While the theory is interesting, detecting one of these elusive objects is a huge challenge. If we could find one though, it would not only explain these gravitational anomalies, but it could also offer profound insights into the early universe, the nature of black holes, and even the mysterious nature of dark matter. Could it be that a primordial black hole is lurking just outside of our detection range, influencing our solar system in ways we don't yet fully understand? It's a fascinating idea, and as our technology advances and our understanding deepens, we may just be able to uncover one of these ancient invisible objects. As we've explored these possibilities, it's important to remember that science is not about being right or wrong, but about constantly questioning, testing, and refining our understanding. Each new discovery, every observation, every theory, brings us one step closer to unraveling the secrets of the universe. So what's the answer? The truth is, we don't know yet. But that's the exciting part. And that's it for today's dive into the mysteries beyond our solar system. So what do you think? Could one of these theories explain the strange gravitational effects we've observed, or do you have your own idea about what's out there? Let us know in the comments below. And if you're curious about the evidence behind Planet 9 itself, don't forget to check out my previous video. If you enjoyed this exploration, don't forget to like, share, and subscribe for more cosmic mysteries and scientific wonders. Thanks for watching. Until next time, keep looking up.